engine coolant temperature sensor is right in there. It's this brown wire, that's the signal wire. Our intake air temperature sensor is included with the NAF. It's right here. You got the harness right there. Okay. So we're measuring the signal voltage of the engine coolant temperature sensor while the car isn't on, so like 70 degrees Fahrenheit. And the voltage we get is on the multimeter right there. It's 0.03929, something like that.
And to put that voltage into perspective, that's when the ECT is running at 69 degrees Fahrenheit.
So on AllData, you can find this graph that'll show you the expected resistance values for the various temperatures. And you can see that there is a range that is acceptable to be in when testing.
All right, so what I'm doing here is I'm just shorting the two sensor wires. So I'm going to short this one like so, and it should cause the ECT to read at high temperature.
Probed into the mass airflow sensor right here on the back of the intake. Okay, we're gonna measure with our little pin on our multimeter, and the voltage we get is 0.039, which is gonna be the signal voltage.
And for that voltage, the IAT is reading at 71 degrees Fahrenheit.
And to properly test the resistance of the intake air temperature sensor, you would probe between E2 and THA with an ohm meter, and then you could receive those expected values.
Okay, here in the RAV4 we got the scan tool plugged in, and we're looking at the live PIDs right now. Currently you could see that the engine coolant temp sensor is at 69 degrees Fahrenheit, and then the IAT intake air temp sensor is at 71 degrees Fahrenheit. My partner over here, Chuck, is going to unplug both of them, and we will hopefully see them change. Yep, ECT is at -40 now, so that dropped, and also the IAT has also dropped. Okay, so right now we have the multimeter hooked up to a no good ground, obviously because it's on the negative battery terminal, and we have the red lead connected. It's back probed into the 5-volt signal, the actual sensor signal to the PCM. Right now with the throttle closed, you can see that it's reading at 0.59 volts, basically 0.6 volts. And then we're going to do a quick sweep test here just to show you how the voltage increases as you increase the throttle input. We're looking for smooth operations, see if, to make sure that it doesn't dip into any weird readings like that. Oh no, I just got disconnected from the back probe here, so let me restart. And that would be wide open throttle right there at around 3.899 to 3.9 volts.
So on AllData, you can find a diagram that'll show you what your resistance values you're supposed to get between your points. And just to start, your VTA is going to be your signal, and E2 is your ground. So at throttle valve fully open, you can get anywhere from 2 to 10 kilo ohms. And then when your throttle's closed, you can get anywhere from 0.2 to 5.7 kilo ohms. And then from your just regular 5-volt power to ground, so across the resistor, you can expect 2.5 to 5.9 kilo ohms. So we're doing a resistance sweep test on a throttle position sensor. So you can see on the multimeter here, this is going to be at closed throttle. And then when we move the little thing here, you can slowly sweep, and you get open to wide open throttle, and then you go back down, making sure there's no brakes and no like stops in the resistance. It goes out of limits, and then this is how you tell if it's good or not.